Hi, so today we're going to do a bit of a lesson on the mathematical equations of motion. This is proper science, proper physics. If you can do this, any physics question in any exam or any test will seem really simple. It can seem a bit confusing at first, but don't worry, I'll walk you through it. Let's just get things going nice and simply with some starter questions. Can you state 5 different units you could use to express speed or velocity? And what's the difference between distance and displacement? A car is traveling 15 meters per second east. A truck is going 15 meters per second west. What is their relative velocity? Now both are traveling 15 meters per second east. What is their relative velocity? Pause, answer the questions, and unpause when you're done. Check. Okay, 5 things you could use to express a speed or velocity. So let's get the pen working. So down below we've got meters per second. You could do miles per hour. You could do kilometers per second. You could do kilometers per hour, or you could do something really big like kilometers per millisecond, just to be awkward. What's the difference between distance and displacement? Distance and displacement, often simpler to perhaps do a little diagram. This is A, this is B. The displacement is how far A is from B. The distance, well, I could have taken a really roundabout journey and got completely lost. And the distance was how far I travelled. The displacement is the difference in position between A and B. A car is travelling 15 meters per second east. 15. Another one is travelling 15 meters per second west. What is a relative velocity? Well, if one's going this way, one's going that way, maybe say this one is minus. So in reality, their relative velocity is 30 meters per second. Now you could say, if you place it from this car, it would be east and that car would be west. So it's all relative. Both are traveling 15 meters per second each. What is their relative velocity? 0. They're both traveling at the same velocity in the same direction, going next to each other. You look out the window, the other one doesn't appear to be moving relative to them. So, if we're going to do some equations, it's often simpler to do equations in the form of symbols. But the problem is, the symbols don't always make sense. And so I'm going to introduce you to them. And if there's anything you're going to write down today, these are it. So when we're talking about displacement, we don't use the letter D. D is used for diameter or density or other things. But no, we don't use D for displacement. We use S. I Googled it earlier to find out what it means. S stands for spatial location. And it should be the difference between two spatial locations. If we're talking about displacement, we actually use the letter S. I know, confusing. When we're talking about velocity, normally we're talking about a velocity that can change. So velocity, you can just do V for velocity, but actually, if something's accelerating, we use V for final velocity and U for initial velocity. So it starts at U and it ends at V. If the thing's not accelerating, we'll just use V. Acceleration is A, lowercase, and time is T. All of these are lowercase. Capitals mean different things. Capital T is temperature, capital A is area, capital B is volume, capital U is, what is capital U? I don't know. I know, uranium. And S is capital S. No, I can't remember. All of these things still measured in the same units. Meters, meters per second per second, or meters per second squared. Those two things are the same thing, just different ways of writing them. And time is measured in seconds. If we're doing speed, distance, time, it's probably easier from now on just to write them as speed, distance, time. So if you've not done anything, pause, write those down, and unpause when you're done. Excellent. So, don't be scared. These aren't scary at all. This is just some of the equations. They're called the SUVAT equations because we have the letters S, U, V, A, T. They're in capital there, which is exactly what I said they were. I apologise. And you've met most of these equations already before. This equation down here is one of the few equations in the exam will be given to you. You don't have to know that off the top of your head. That one is given to you in the exam, but you need to know what it is. These two are actually the same equation. They've just been rearranged to make it easier or harder, depending on how you look at it. So this one, acceleration is equal to change in velocity, v minus u, all divided by time. And actually, you can see how these two are the same. Because this is divided here, we bring this up here, it becomes a times time, which is what we've got here, a times time. And then that would be v minus u equals a times time. Well, if we just plus u to that side, plus u to this side, we got the two same things. If you were doing exams this year, I would suggest that you wrote these equations down on a piece of paper and stuck them somewhere on your wall so you could see them all the time. It's what I did at university, loads of equations all over my room and the house, and just so wherever you were, you could see these equations. So when you're doing them in the exam, they just come into your head much quicker rather than having to really think about it. These should just be kind of hopefully second nature. This one is actually u plus v over 2. Well, that's just working out the average. So that's the average velocity. Average velocity times time is displacement. You knew that equation already. I've just given it to you in the form of letters. And this last one, this one's tricky, and I'm not even going to show you how we come from it. You just have to believe in us. And this is v squared minus u squared is equal to 2 times a times s. You could rearrange it. So you could maybe, if you want to find acceleration, you can have v squared minus u squared all divided by 2 times s, and that equals a. Or you could switch them around. V squared minus u squared all over 2a equals s. Or you could do v squared equals 2as plus u squared. That's a plus. There are different ways to use these equations. So what I'm going to do is this is the rest. That's all the information I'm going to give you. Now we're going to do a few equations, calculations as a practice, and then the rest are up to you. All of them will just require you to use these same things. Here we go, first one. A car accelerates steadily from rest at 4 meters per second for 3 seconds. Find its final velocity, find its average velocity, and find the distance that it's traveled. If you're doing any question with these equations, the first thing you should do for all of them is this. S, U, V, A, T. And then once you've done that, write down what you know. So we know time is 3 seconds. T, 3 seconds. We know A is 4 meters per second. 4 meters per second squared. Sorry. We also know another thing. It has told us something else, but it told us in a kind of, not secretive way, but in a way you might miss. It tells us what the initial velocity is. It tells us the initial velocity is 0, because it says a car accelerates from rest. Rest is not moving, so that means it has 0 meters per second. So now we know 3 different things, and we just got to work out one more. So what's the best equation to work out the final velocity? If I go back to here, this equation here, V equals u plus at. V equals u plus at, which is just u, 0, plus a, 4, times t, 3, equals 4 times 3, can you put in your head, 12 meters per second. Simple. What's its average velocity? Average is, so you've got u plus v, u all over 2. We've got 2 values, so the average or the mean is when you add the numbers together and divide by how many there are. So this is 0 plus 12 all divided by 2 the average velocity is 6 meters per second. And you know it's 6 meters per second because it makes sense because it starts at 0 and ends at 12. The average is halfway between the two. The distance that it has traveled. Okay, so look at this lovely equation. S is the distance displacement, and T is a time. So we do S is equal. Oh no, that's not equals. Equals to U plus V all over 2 times T. Well, we've already just done that part for the previous question. So it's equal to 6 times, and the time was 3. 6 times 3 is 18 meters. No, that wasn't that hard. Okay. Let's do another one. A lorry brakes to stop from a velocity of 20 meters per second in 4 seconds. Find the acceleration. Find the deceleration, the distance traveled during the braking. Okay, first thing we do. What do we do first? You write SUVAT. S-U-V-A-T. Then we write down what we know. Time. 4 seconds. The brake stops from a velocity of 20, so its starting velocity was 20. Ooh. This is 20 meters per second. And then it stops. So what's its final velocity? 0. So we've got 3 things again. So let's go back to our equations. Which equation works? It wants us to find the acceleration. A is V minus U all over T. So A is equal to V minus U all over T. So 20, there's 0 minus 20 all over 4 equals, oops, so it's minus 20 over 4, which is minus 5 meters per second. So it's accelerating at minus 5 meters per second, which means every second the velocity goes down by 5 meters per second. What's its deceleration? Aren't they basically the same thing? Yeah, deceleration is telling you how much it's slowing down. So deceleration is just 5. We don't need the minus. And the distance traveled during the braking. We can use the equation that we used in the last question. S is equal to U plus V all over 2 times T. So that is 20 plus 0 all over 2 times 4, which is equal to 10 over 2. No, not 10 over 10 times 4. Sorry, which is 40 meters. Okay. Hopefully, this is making sense. Not doing anything too crazy. Got some nice numbers. What are the meaning of the signs you were given in your answers to part A and B of question 2? So, A is negative. It's asked for the acceleration. Acceleration is how fast you're going, how fast you're increasing your speed. So because it's negative, we're not increasing speed, we're decreasing speed. So I put that as negative. Actually, it came out as negative. The calculation was negative because it was 0 minus 20. That's minus 20 divided by 4, so it's negative. But when it asks for the deceleration, it's already asking about slowing down. So if you put a minus with a deceleration, a minus deceleration is actually an acceleration getting faster. So that doesn't make sense. So acceleration that is slowing down is negative. Deceleration is still slowing down. It should be given as positive. Right, we'll do one more example and then I'm going to leave it to you. A cat called Lottie accelerates from 3 meters per second from a velocity of 4 meters per second to a velocity of 8 meters per second. How far has she traveled during the acceleration? Do the SUVAT. S, U, V, A, T. What do we know? We know the acceleration. A is 3 meters per second squared. It starts at 4 meters per second and it finishes at 8 meters per second. How far have they travelled? Okay, so we've got u, b, a. Let's go back to our equations. That is this equation here, v squared, u squared, 2as, but actually it wants us to know s. Already rearranged it here, v squared minus u squared divided by 2a equals s. So let's stick this value in. V squared minus u squared all over 2a equals s. So 4 squared, no, sorry, 8 squared minus 4 squared all over 2 times 3 equals, do this on my calculator because I can't do it in my head. So 8 squared minus 4 squared divided by 6 equals 8 meters. Quite simple. So what I'm going to do, leave this one with you, but I'm going to help you. We'll start you off. First thing, SUBAT, S-U-B-A-T. What do you know? They accelerate from 15 meters per second, so that's u. That's 15. They know the acceleration is a is 5, and t is 3. There we go. So, how far do they travel during the acceleration? So, what do we know? You can use the equation v equals u plus at. That'll give you the final velocity, and then you can stick it into any of the equations like s equals u plus v all over 2 times t. There's a good way. So do this equation to work out v, and then you can use the v to work out the distance travelled. That'll help you for that question. Let's have a look at another one. SUBAT, S-U-B-A-T. They accelerate for 2 seconds. T is 2 from 20 over a distance. S is 50. What is the acceleration? So, what do we need to know? We need to know acceleration. This one is a bit trickier. B squared, U squared. No, we don't know that. Let's check what is the acceleration of the dragster. So we need to do look at the equations. If we do S equals U plus B all over 2 times T, I could rearrange that one. So I could do S over T equals U plus B all over 2, and then bring that 2 across. 2 S over T equals U plus B. So we know S, we know T, we know 2, and then we know U. So you can then work out what V is. That one's a tricky one. This one, at the start of a race, a powered boat accelerates from rest with an acceleration S-U-B-A-T. So from rest 0, S8 A is 4. So this one you can use the equation v squared equals u squared plus 2as. Then once you've worked out v squared, you can do one of the other equations to work out the time. So you could either do s equals u plus v all over 2 times t, or you can do v minus u all over a equals t. Okay, I've given you lots of help. Hopefully, you'll be able to do these. I'll do a working solutions one a bit later. Okay? And the last one, lots of information on the page. Okay? I'm just going to read through this one. A child drops a small stone. Here's important. All of these questions, A is going to be equal to gravity. That's 10. So when you're writing your SUVAT, SUVAT, automatically, you know 10. Okay, but A. A small child drops a stone from a well. Here's a hit at the bottom after 2.1 seconds. 2.1 seconds. He drops it. U is 0. Calculate the speed just before impact. So that's B. And the distance, S. Easy. A cricketer throws a ball vertically in the air. The ball takes 3.8 seconds to return. So here's my cricketer. Imagine it's Mr. Williams with his cricket stuff. He throws the ball up and then back down. That looks inappropriate. This whole journey takes 3.6 seconds. 3.6 seconds for the whole journey. So how long does it take to get to the top? The last one, you can do it. Okay, loads to do. Good luck. Love you. Bye.